Hello, everyone, and welcome to the 2021 Roundtables USA. I'm David Wagman, Senior Editor at PV Magazine USA.
And I'm Tim Sylvia, Editor with PV Magazine USA.
This year's Roundtables convene at a time when solar PV enjoys unprecedented support at nearly every level, public and private. Innovation is driving technology advancements, and demand for clean energy solutions has never been higher. Everything from rooftop PV to utility-scale storage to electric vehicles.
But challenges remain to be addressed. Primary among these are supply chain difficulties and international trade uncertainties. A further challenge is determining exactly how the industry can ramp up to meet the Biden administration's ambitious clean energy and emission reduction goals. Looming over all of this is the existential threat posed by climate change. More severe storms, the growing threat of wildfires, and rising temperatures all have practical operating consequences for solar assets.
Over the course of our morning and afternoon sessions, we'll work to put all of these factors into context. Our aim is to offer insights into the pivotal role that solar PV and clean energy will play in addressing climate challenges and the economy-wide push to decarbonize. There are lots of ways that you can get involved, and that includes right here on the main stage by submitting your questions to our speakers and panelists. On the event app directly next to the live stream, you can send us your question or comment. You can even upvote other people's questions when it's something you'd like to have addressed. Get involved. We're looking forward to hearing from you. Tim, what can our audience look forward to today?
Well, in a few minutes, we'll start our first Roundtables session, which focuses on the rising stakes for solar and storage. We'll examine issues related to quality and performance from multiple points of view. We'll start with a macro view of the critical issues facing solar and energy storage, and then drill down to the more detailed discussions of inverters, trackers, and modules.
During our networking break, take some time to explore the expo area and have a look at the booths full of industry-relevant information and videos, articles, and more, or strike up a conversation with our partners. PV Magazine USA's Ryan Kennedy will be there as well. And the networking area offers the chance for you to create and build connections in a series of instant one-on-one exchanges. These 5-minute sessions are popular, so be patient to meet with your next contact.
Following our networking break, we'll reconvene for the day's second Roundtables session. Here we'll focus on the practical steps that need to be taken to achieve the Biden administration's call for a 3 to 4 times expansion of solar deployment. We'll also look at the technical innovations which are helping to expand the use of PV, energy storage, green hydrogen, and electrification across multiple sectors, including the all-important transportation sector. Of course, all this innovation is enabled by supportive policies at the local, state, and federal levels.
None of this would be possible without the support of our networking partner, Recom, and our platinum partners, Clean Energy Associates and Longi, as well as our gold partners, whose names you can see on our multimedia wall. Thanks to all of them for their support of today's event. It's going to be a full day, so let's get started. In just a few minutes, we'll have our first panel discussion, whose focus will be on the effects extreme weather events and climate change are having on solar installations. But before that, Tim, would you like to introduce our first speaker of the day?
Thank you, David. Absolutely. As the tangible effects of climate change become more a part of our existence, the need for a power system which can withstand the destruction that these events bring and deliver electricity reliably to the people who need it most becomes paramount. This past year alone, dramatic weather events in Texas and Louisiana highlighted the shortcomings of our current grid as tens of thousands of people across both states were left without power, even as their states experience record stretches of freezing temperatures and the devastating winds and flooding of a powerful hurricane. These types of weather events aren't going away, so it's on us to design a system that can withstand such acts of nature. In this light, our first speaker today is Karla Loeb, Distributed Generation Division Chair with the SEIA Board of Directors and Principal for Loeb Clean Energy Consulting. In her position, Karla oversees legislative, administrative, and regulatory efforts at the local, state, and national levels. She's also a Louisiana native and former Texan, and has seen firsthand the destruction that major storms can bring. Welcome, Karla.
Hi, Tim. Thanks for having me.
Of course. Thank you, Karla.
Hi, everyone. Thank you so much for inviting me to come and speak to you today. Again, Karla Loeb, native New Orleanian, recovering Texan, and currently reside in Washington, D.C. As so many of you know, the rising tide of climate change and extreme weather events has had major implications and ramifications around the country. The past year alone, we have had $130 billion worth of effects in the state of Texas as it related to Winter Storm Uri. And in Louisiana, the estimates currently are running about $95 billion for Hurricane Ida. More than 900,000 people lost power during Hurricane Ida because of the extreme winds of 140 degrees and above. Winter Storm Uri had temperatures dropping well below freezing, and sustained outages lasted for 42 hours on average, 52 hours on average for people without water. The four major issues of global warming impacts start with hurricanes. Hurricanes are the #1 impacted thing. Real estate losses, energy costs, water costs. Why am I talking about the costs? I'm talking about the costs because we can't afford not to make changes to our current infrastructure. The cost of climate change right now is estimated by the NRDC to cost $1.9 trillion annually going forward. This is 1.8% of the US GDP per year by 2100. With hurricanes being the most expensive disasters that we see, there are also unforeseen impacts like bankruptcies rise and are likely to result. Young people who survive major hurricanes are less likely to attend college. It takes longer for people to graduate. Hurricane survivors have long-term mental health problems, and that doesn't even include other effects that are not mentioned. We have agriculture issues that are unaccounted for, telecom disconnections that are not accounted for. This is all a very dire situation. Yesterday, we ended COP26, where people from around the country joined in Glasgow to discuss what we needed to do and the commitments we needed to make to change things. Some of the commitments that occurred included 100 countries signed methane pledges to reduce methane by 2030. India with a net zero $30 trillion.
We lost Karla. We're going to try to get her back in a minute here. And if we can't get her back, we'll move on. But even if not, thank you, Karla.
Are we having?
We have Karla
Tim?
back. We have Karla back.
Oh, what was the last thing you heard? 130 countries pledged to halt reverse forests by 2030, and 70% of $100 billion annually in climate finance to low-income groups. These are huge commitments, but it's not enough. We need activation and engagement on the local, state, and federal level to combat these challenges and the challenges that are seen before us. The Build Back Better plan, which is currently before Congress, includes several things that are going to help us fight climate change. Most of all, in the solar industry, we're talking about the long-term extension of the solar ITC. We're talking about manufacturing tax credits. We're talking about Section 25D tax credits refundable so that we can make solar equitable to everyone. Standalone ITC for energy storage. Why is this all important? We need to start thinking about our grid in different capacities and ways. Our extreme weather events have shown our massive vulnerabilities in the face of climate change. And so we have to stop doing business as usual and start thinking about what our energy infrastructure of the future is going to look like. Telecommunications has dealt with this for years and started to think about what the future is going to look like. It's time for the energy industry to do the same. FERC 2222, that was issued by the Federal Energy Regulatory Commission, started to lay out and has begun to lay out a framework to allow for direct engagement between individual households, and energy markets, which means you can make money off of selling your energy and services to regional transmission organizations or generally the energy market. This is going to be really important going forward. We need to start thinking about energy on a distributed basis, but we have massive utility scale solar and wind farms, offshore wind goals, transportation electrification, which are going to be paramount to meet the climate change challenges. The truth is our energy infrastructure needs to be more resilient. And the way it becomes more resilient is making that energy infrastructure more distributed. More distributed means more residential solar, more battery storage at individual households, and it means community solar to power communities rather than remote utility scale solar infrastructure and energy wind infrastructure in remote locations. We need to have energy where people live, not just to power our large manufacturing industries and industrial industries. So as we look to the future, we think about what happened in New Orleans. Hurricane Ida, 140-degree winds. We didn't even have serious flooding in the city of New Orleans, and more than 900,000 people were without power. So what does an energy future look like potentially in New Orleans? In my opinion, I think that it looks like residential solar on every rooftop in the city with community hubs of solar for community solar for those people that can't install solar on their households. I think it's battery storage units at every house. So when the power does go out, because it's not an if, it's a when, people still do have power. People who have health issues, who are on ventilators, who are diabetic and need dialysis can continue to operate and function in day-to-day reality. It's where Texas, where you have solar and storage in the face of drought so you don't lose water resources so that your pumps work when you're in remote areas. It's community solar in communities, supporting communities as energy hubs. All of this is possible, and it's possible if we pass the Build Back Better plan. The Build Back Better plan will be the backbone for the United States to create a new energy paradigm, a new energy infrastructure. And we need to do everything that we possibly can to pass it, to invest in it, and to invest in our futures and the electrification of the United States infrastructure. And with that, Tim, I'm going to turn it back to you. Call your congressman, support Build Back Better. Let's get prepared for our future.
Thank you. Sincerely thank you, Karla, for that insight into an issue that's only growing in importance. And that actually leads us right into our first panel of the day, Strategies to Harden Solar Assets from Climate-Driven Wind, Hail, Heat, and Fire Threats. Those weather phenomena are some of the most commonly faced and destructive events that PV installations will be tasked with withstanding. Our first panel here will address specific steps that solar array owners and operators can take to better protect their assets.
Joining us on this panel are Nicole Jackson, senior member of the technical staff at Sandia National Laboratories, Jenya Meydbray, CEO of PV Evolution Labs, John Sedgwick, president of VDE Americas, and Chris Thellen, product development engineer with Endurans Solar. Thank you all for joining us. Tim, over to you.
Sure thing. I'd like to address this first question to everyone in the panel, and if you could give just kind of a very brief answer to this. What factors do you each think have had increased operational risks for solar projects? And Chris, why don't we start with you and then move down the line?
Well, good morning, and thank you very much for the introduction. As you mentioned, we're facing higher temperatures. We're facing issues with more extreme environments. And protecting our modules and creating a solar infrastructure that can survive these extreme weather phenomenon and be in service longer is just going to give us a better opportunity for driving the cost of solar down and keeping our infrastructure built. Endurans Solar is focused on creating longer lasting and high quality products that will go into the manufacture of these modules. We know that these back sheets and other products that go into these modules are the first line of defense in creating a module that will survive these environments. So we create materials that are high quality and long lasting. We can have more confidence that our solar systems are going to survive these elements. We're talking, again, high temperatures, high winds, blowing debris, anything that can keep our modules longer lasting and have the confidence that the power is going to be there when we need it.
Thank you, Chris. John, on to you, same question.
Yeah, I think the first issue is to understand the frequency of these events. And that's what we've been focusing on at VDE is building science and engineering-based tools where you can have a much better understanding of the frequency and the severity of these events. In solar, related to hail specifically, much of the solar installations historically were done in rather benign hail environments. Recently, however, because of incentives, solar installations have been put in places like Texas and other areas where the hail situation is much more severe. And I think it took the industry a little bit by surprise. Shouldn't be. When you think of putting acres and acres of glass out into a hail-prone area, you might have an issue. But what we're finding is that if you can operate the equipment appropriately, select appropriate hardware at locations, and understand what the severity and the frequency of these events are, you can mitigate significantly the risk. And the other factor is that insurance plays a very important role. And so we feel our function is to provide the insurance industry with science and engineering-based bottoms-up analysis that they can base on terms and conditions that are acceptable to both the insurers and the people who are being insured.
Thank you very much, Sean. Jenya, your take?
Yeah, thanks for having me here. I think to echo some of the things that John mentioned, I think the biggest factor of contributing to increased incidence is just geography. There's more and more solar going into more and more hail-prone regions. Texas has the largest utility-scale solar pipeline, and in the U.S. and, coincidentally, the largest number of hail events. So at PVEL, we do field testing and hail testing in the lab. The field testing we do is typically to support insurance claims or post-construction, and we've been deploying our field crews more and more and more to Texas and mostly West Texas. So the second thing I think is just a huge proliferation of module technologies over the last 24 months. In the lab, we've seen wafers grow, cells grow, modules grow, glass is getting thinner, glass modules. With thinner glass, you have untempered glass, which has different strength properties. So just a huge proliferation of module technologies and geography, I'd say, are the two biggest factors.
Thank you very much, Jenya. And then to round out kind of this first question, Nicole.
Yeah, thanks for having me. I would also similarly echo everything the panelists said. And from my perspective, from the research side of things, siting has opened up a complex set of conditions that these panels and sites are facing in terms of previously unprecedented or unthought of different types of hazards that may occur. So moving just beyond hail, but thinking about increases in temperature. Maybe now you're moving into a site or region that is expected to have higher winds than you may have previously thought during the design phase. And so as we think about moving into different geographies, it opens up a lot more risk to just different types of weather phenomena.
Thank you very much each for your answers to that. Nicole, I'm going to stay with you for the second question here. And John, after that, I would like to hear your perspective as well. In your opinions, are we being holistic enough in recognizing and prepping for all the phenomena that a given project should?
Well, I think the short answer is no, but it's a little bit more nuanced than that. I think we're at a point where solar is becoming mature and we have enough data streams of information where we can start to be more holistic in terms of what's happening on the ground, in terms of operations and maintenance, what's happening on the actuarial side in terms of like risk products, and what's happening in terms of weather phenomena. And there's lots of different ways that we can capture all of that data. And so I think we're at a point where we can become more holistic in recognizing that there's a lot of different factors that we need to include as we're designing these sites and taking care of them.
Thank you. John?
Yeah, again, as I mentioned earlier, I mean, what we're doing is we're getting our arms around a very complex situation when you're dealing with weather and natural phenomena. What we've been focusing on is building tools where we can get a much better understanding of what the return interval is of these events, such that you can build appropriate systems to survive these events at a rate where insurers and investors can accept those risks. So our first step in our analysis is you need to understand weather. You need to understand what the frequency of the events are, and they're very location specific. So you need to understand what the return interval of these damaging events are at these specific locations. After that, then you need to understand what's installed at that location and what the resiliency of the equipment that's been installed there is. And then finally, how it's operated. And when you put those all into a system analysis or a holistic analysis, then you get a pretty good picture of what the actual survivability is of that system. Then you can overlay on top of that what the insurance industry requires, and you can come up with rational insurance pricing and terms that are acceptable to all parties. And what we found is that if you select the appropriate equipment, if you operate it appropriately, you can provide significant mitigation against these events.
Thank you very much. John, I would like to pose this next question to you as well, and then Jenya, again, I would like to hear your perspective. And I know you work a lot with hail, John, which is a relatively, in terms of PV, new phenomenon. So in that light, do our current testing standards, and not just for hail, across all weather events, represent realistic exposure as to what projects we'll see in the field, and then kind of as a preliminary follow-up, if not, how and what needs to be changed with those standards to more accurately reflect what a project will face?
Yeah, we focus primarily on hail, although the statistical methods that we've developed can be applied to other situations like tornadoes, hurricanes, and flooding as well. But yeah, the current standard, the IEC standard, which Jenya is very familiar with, was pretty much inadequate for trying to do any kind of analysis of financial risk associated with installing multi-$100 million assets in hail-prone areas. IEC is working on that in that they're developing a TS. It's an upgrade to the IEC standard. We're involved in that. Jenya is involved in that. Full disclosure, VDE has a controlling interest in the competitor of Jenya's called RETC. So I want to make sure that that's out there first. RETC is involved in it as well as many other industry participants in trying to develop an improved hail resiliency testing. Jenya will tell you a lot more about PVEL's process that they're doing to provide substantially better testing information, and RETC has a hail durability testing protocol that provides significantly more information than what the IEC standard had. But what we need in order to plug valuable information into our models is true hail resiliency measurement. And we're working with a number of module manufacturers to do very comprehensive hail resiliency analysis so that we can get a true understanding of how these products perform in the presence of damaging hail.
Thank you very much, John. Jenya?
Yeah, so I think the short answer to are the standards sufficient is no. The certification standards today are not sufficient. But as John said, there are folks trying to improve upon the existing standards. So PVEL's offered our PVEL Product Qualification Program, or PQP, which is an extensive testing program that includes a hail stress sequence, also includes a mechanical stress sequence, which may be less relevant for hail, but is very relevant for high wind, which is increasingly relevant as the modules grow bigger and bigger and bigger and are just like a sail out there catching the wind. We've seen mixed results from the hail testing and from the mechanical stress sequence testing. Some of the panels do better than others when impacted or when deflected. Ultimately, when John and the VDE team are doing an assessment of the whole plant's risk to hail, it starts with the product's risk to hail or the product's resiliency. And so that's where PVEL can help evaluate the robustness. When we've sent our field crews out into the field post-hail event, typically there's a concentrated area where there's a lot of breakage and a lot of damage. And, in West Texas, the hail can get the size of a grapefruit, and we don't expect any panels to survive that. And they shouldn't, because if they do, you're probably for every other application. But then as you expand out from that center of damage, the hail gets smaller and smaller, and you start to see different levels of damage around the edges. And that's where really module robustness to hail plays a big role of where that perimeter is, where the damage stops. And so PVEL can really help there. We've evaluated over about 1 gigawatt of operating plants, and these are pretty consistent trends that we've seen.
Thank you very much, Jenya. I understand we have a bunch of audience questions starting to roll in, but before that, Chris, it's been a minute, and I don't want you to feel like you're ignored. So do you think, and John, feel free to comment on this after, do you think market conditions could evolve to feature products specifically designed for certain weather conditions, certain types of robustness and resilience, maybe defined by climate or geographically?
Oh, absolutely. As a material supplier, we have a critical interest in making sure that materials we supply to module makers are going to survive. And as you know, the IEC and other module standards are sort of built around a general weather pattern. We're seeing more and more of the certifications and the test methods being developed for these more extreme environments. But as you said, a general weather standard is not going to be well equipped to handle high humidities in a certain area, an extreme UV irradiance that might be seen in certain parts of the earth. So we do know that there are test methods that are being developed by the labs. PVEL, NREL is doing some wonderful work in developing these test methods for extreme conditions. So we feel that it is important, especially to the module makers, to seek out these specific tests to know how these panels and these modules are going to perform in specific areas of the world.
Thank you very much, Chris. John, anything to add there?
Yeah, I think something of significance is not only the equipment that's being installed, but how it's being operated. What we're seeing is a trend towards utilizing SCADA systems to take signals from weather service providers that will, for example, set your tracker into its optimal hailstone position in advance of forecasted damaging storm. And by doing that, you get substantial mitigation to the potential damage of a storm. So its appropriate operation could be a critically important aspect, as well as hardening in general things like modules for their hail resiliency.
Thank you, John. Thank you. David, would you like to get into the first of our questions here?
Yeah, and this is a good reminder to the audience also that if you have a question, please go ahead and send it to us. But this question is inquiring about what additional procedures we may need to develop in order to install the modules, and this is specifically around installation and spec of trackers for hail affected areas. What can you add about the balance of system considerations that we may need to bring into the mix?
I'm happy to provide a few comments there. So,
yes, thank you.
Sure. So we've all seen panels getting bigger and bigger and bigger over the last 24 months, 18 months. Of course, when a panel gets bigger, it catches more wind, and that has to be considered in the racking and structure design. As the panels get bigger, especially with bifacial, a lot of folks are moving to glass. They have to thin the glass out because if they use thicker glass, it's too heavy. So what we've seen is a lot of 2 millimeter glass, less than 2.5 millimeter glass. It can't be tempered, so all of these mechanical impacts have a bigger consideration, I think. Additionally, as the modules grow, the electrical specs grow, so the optimal number of modules per string or per tracker row length is going to change. So I think these are all complicating factors. I think it's great that Jinko, JA, and Longi announced an effort to standardize module specs and module dimensions. I think that'll make the tracker manufacturers' lives quite a bit easier to design to one optimal module. So there are definitely considerations when it comes to the racking and the tracker design with larger modules.
Mm-hmm.
Yeah, and I can just add to that. I think tracker manufacturers are doing a very good job of recognizing that they can be a significant contributor to the resilience of the system. So they're designing their systems with optimum hail stow procedures or optimal wind stow procedures, not only during the operational phase of a project, but also it needs to be considered when you're constructing a project. So when you're in the middle of construction, where do you set your trackers such that you can minimize damage in the event of a storm? So yeah, the module manufacturers are working to, number one, understand what the true resiliency of their current systems are. They're also working on techniques to make them more resilient. And the tracker industry in general is doing an outstanding job in recognizing that hail stow procedures is a critically important aspect to the overall value of the investment through its lifetime.
Appreciate the perspectives, gentlemen. Nicole, I understand that a lot of your work in the past year, you've been working a lot with project owners and going through kind of warranty claims, maintenance issues. Could you give us a little bit of perspective as to what the extreme weather warranty landscape is like, and who's on the hook when hardware is destroyed and production is interrupted?
Yeah. Great question. So what we've seen from some of our industry partners, and we currently work with about 6 of them throughout the country, is that over time, the warranty landscape has become increasingly challenging as more events have occurred. And so as my other panelists have alluded to, hail has definitely been a critical issue in this sector. And the warranty landscape has responded by increasingly not covering hail-related damages. And so it's from our perspective on the research side of things, it brings into bear some thoughts on, well, as we move away towards, you have these highly impactful events that can really, really decimate a site. What does that mean as we go forward and we start to see more compound events or more chronic events? So maybe your site is exposed to a lot more higher wind speeds than you previously expected, or now you've moved a site into a place where you're now factoring in snow loads and things like that. And so there's kind of a mismatch between what's happening from warranties and what's happening in the field. And unfortunately, for some of the owner operators that I engage with, they are increasingly subject to that exposure on the risk and financial side of things. So hopefully we can get to a point where both parties are working in concert to minimize risk to these types of events to ensure continuity of services.
Thank you very much, Nicole. David, I'd like to turn back to you and see if we have any more submitted audience questions.
Oh, we did. Yeah, there was a question. We've talked a lot about utility scale solar, and the question is around the lines of where residential and some of the integrated solar with roof tiles, where that stands in relation to some of these issues. Is there any protection, any much work that's being done with residential and with integrated solar, or is it mostly at this point at the utility scale that the interest is being shown? Nicole, do you want to start with that?
Sure. Yeah. On my side of things, most of the work and most of the data that I have access to comes from the utility side, but there is emerging interest in distributed systems, and those are seen as a potential source of energy that is readily accessible, and particularly if you think about things from an equity standpoint, and under-resourced communities, that some of that deployment could help improve energy equity in that aspect as well. But unfortunately, right now, a lot of my work just focuses on utility scale.
Any other comments, or we're mostly focused at the utility scale?
Well, if I can comment on the residential, obviously, these modules are being used both utility and residential areas, and where we're seeing a lot of interest is along the area of building integrated. And along with building integrated and the residential side, we're talking about fire ratings. The difference between class 1, class 2, type 1, type 2 modules, especially with a lot of the rules and regulations that are coming out of the state of California, there are more specific requirements for these modules that are going into residential applications. So from the material side, we have more interest in materials that are fire retardant. There's a lot of interest going into clear materials for bifacial modules, glass modules, and modules that have clear materials in them. So there is a large interest in fire ratings. How do we supply materials that can protect a homeowner in the case of a fire? And how do these modules rate in terms of fire safety?
Very good, thank you.
Yes, thank you for that perspective, Chris. We only have a few more minutes here left in this panel, so I'd like to address one kind of last question here, starting with Jenya and Nicole, and again, anyone else feel free to contribute to this. So a lot of the conversation around extreme weather and insurance has been framed differently in the past 18 months or 2 years since the Midway event in Texas, when that 170, I believe, megawatt project was essentially destroyed by a hailstorm. And that kind of reset the insurance market. It has caused people to rethink how underwriting and how covering projects like that even works. And so what I wanted to ask here is, how can a mature risk market be developed before a resetting or force majeure event like Midway makes one necessary? And Nicole, if we could start with you, and then Jenya, that'd be nice.
Yeah, I think there's room to grow in this sector. I think we're at a point where we have a lot of, and particularly coming from the weather and climate data set side, that we have a more sophisticated and nuanced understanding of what some of these events are that we can forecast or project into the future. As well as folding in other temperature scenarios, wind scenarios, and so forth. And I think we can, from the computational side of things, create very complex scenarios that can be ingested into some of the more catastrophe modeling and some of the work that folks like John do, to have a more realistic picture of, with a fair bit of uncertainty, of what potentially some of these sites may face. And I think there's an opportunity to form a robust feedback loop between what some of the scenarios are being generated, what are some of the risk products forecasting or anticipating, and how can we have this like back and forth to see where these products can properly align, given what we know potentially about the future. So I think there's room to grow, and there's a lot of really fun opportunities out there for industry researchers and owners and operators to work together to have better products available.
Thank you. Jenya?
Yeah, I think that it's really a matter of education of both sides, of the asset owners and the insurance providers. There's nothing that motivates really fast coming up the learning curve like a $75 million Midway insurance claim. So that forced the insurance market to learn things really fast. But since then, of course, as you said, the insurance market has hardened. It's been tough times for a lot of the asset owners. We've seen huge variability in policy language, some of which is still very vague, and some of which has exclusions that are not very helpful to the asset owner. As Nicole mentioned earlier, we have seen a trend since Midway for more data and more technical inputs into insurance policies and insurance structuring overall. There's one company called KWH Analytics that's been at the forefront of some of this work. That's great. I'll also put in a plug for, in addition to some of the work that Nicole and Sandia are doing, James Ellsworth over at NREL has done a lot of work and has some good publications out there on hardening solar assets so they can be more resilient in when impacted by a storm. And it's bigger than the modules. It can get, go down to the fasteners and what kind of bolts you use and et cetera, et cetera. So it can get pretty detailed. Overall, I would say today there is huge variability in the insurance market, some of which is helpful, some of which is less helpful to the asset owners. I would highly encourage all asset owners to carefully read their policy language before signing up. A lot of the insurers are asking about cell cracks pre-existing the storm. We've been doing a lot of EL imaging in the field post-construction to get a baseline to support that in the future. And ultimately, I think it has to be more data-driven than it has been in the past.
Thank you very much, Jenya.
Well, many thanks to Nicole Jackson from Sandia National Laboratories, Jenya Meydbray from PVEL, John Sedgwick from VDE Americas, and Chris Thellen from Endurans Solar for their insights and for joining us today. Thanks very much to all of you. In a few minutes, we'll learn more about some of the real-world challenges that the rapidly expanding adoption of large format modules are having. Before that, though, stick around to hear more on this thought train of project resiliency from our next speaker. Resiliency will be a paramount battle for the solar industry for some time, and storms, however well prepared for, can always lead to damage and defects in solar modules. Often the damage is not even visible to the naked eye. Damage to and defects in solar cells can have a major impact on module performance and longevity. A technique known as electroluminescence imaging is used to evaluate the quality of the electrical components of solar cells, actually the contacts of those solar cells. EL testing uses specialized equipment and current flows to create images of the panel that highlight any PV module defects. To help us now understand this useful diagnostic tool is Claire Kearns-McCoy, Senior Project Manager and a solar engineer with Clean Energy Associates, one of our platinum partners for today's roundtables. Claire, welcome. Thanks for being here. Claire has extensive, Claire has extensive experience in conducting and analyzing electroluminescence imaging field tests. She has participated in projects and interpreted test results covering more than 60,000 PV modules. An MIT grad with a focus on energy conversion engineering, Claire spent 3 years at Sun Edison before joining SEIA. Welcome, Claire. Please, your presentation.
Sorry for that. Had a bit of a technical challenge there. But yeah, so underperformance is constantly a hot topic in the PV industry. And everyone knows that module quality is one important way to ensure your project does not underperform. And to that end, quality assurance is already seen as an essential part of the module manufacturing process. Manufacturers will have their own quality assurance programs that they implement as they're making the modules. And in addition, some purchasers choose to add a third-party quality assurance to supplement that the manufacturing quality assurance. While good manufacturing quality assurance ensures the modules are in good condition when they leave the factory, currently a lot less attention is being paid to ensuring those modules stay in good condition throughout the rest of the construction and transportation process. At the end of the day, what matters for your project performance is the condition of the modules as the project is operating. And so what matters is the condition after installation and that those modules stay in good condition throughout the lifetime of the project. Electroluminescence imaging is a really important quality assurance tool. It can be used to detect cell defects that are not visible to the naked eye, such as a microcrack. A module with cracked cells, in most cases, you can't tell at all from looking at it. And crucially, EL also allows you to detect defects that may not currently have an effect on the module power and therefore are not detectable using a flash test or an infrared scan, but have the potential to result in module power loss in the future. EL imaging is already used as part of the factory quality assurance process, and most manufacturers will test their modules multiple times during the process to check the quality of the cells. Using EL in the field can provide that same type of quality check to the modules after they leave the factory and help ensure good module quality. The use of strategically timed EL imaging checks can help you bring the quality assurance to the field. By timing those checks properly, you can identify module condition at various stages of the project lifetime and identify when damage may be occurring and if there's opportunity to remedy that damage. Use of EL can give the asset owner reassurance that their modules are currently in good condition and have not been damaged. Use of EL early in the construction process, such as a post-shipment installation inspection, makes it easy to identify and replace defective modules before they've been installed. It's much easier to replace a defective module during the construction phase than it is to have to send a crew out later when a damage is discovered during commissioning. Additionally, use of multiple steps can let you identify when damage is happening and figure out what needs to be done to prevent that damage from affecting all modules at the project. The first stage where a module is exposed to risk after it leaves the factory is during transportation and shipping. Each pallet of modules is handled multiple times after it leaves the factory, and each handling represents some risk of damage. Additionally, the vibration and thermal stresses that a module is exposed to during transportation can cause additional damage. The most common types of damage we see after transportation are frame damage, glass breakage, formation of new microcracks, or growth and opening of existing microcracks, as shown here. Here you can see a small microcrack that was formed during the factory in the image on the left that's grown during transportation to become a larger crack. There are a few opportunities to assure the quality during transportation, including selecting appropriate packaging, the container loading procedure, selecting an appropriate ground transportation method, and ensuring that modules are carefully unloaded once they arrive at the site. EL imaging is a great tool to verify that all of those procedures are suitable for the condition the modules are being exposed to, and to give you a chance to check the module condition in a post-shipment inspection and verify that your modules were not damaged during shipment. While there is a lot of risk to modules during transportation, in my experience, improper installation procedure is one of the largest causes of modules that are in poor condition in a new or at commissioning period. The types of installation damage we've seen in the field include formation of new microcracks, new branch cracks, impacts to the rear of the module, which can cause backsheet damage and or cell damage, and formation of backsheet scratches. As the type of damage from a module can, if due to improper installation, can range from mild, maybe 1 or 2 cracks have a small microcrack, to some really severe damage, as seen here in this example image. This module has a number of cells that are in very poor condition and is going to significantly underperform. The best way to prevent module damage during installation is through good crew training, a good procedure for installation. And EL is a great way to validate that training and procedure is working as intended. By conducting EL on the same module before and after installation, you can closely track that module and identify new damage that has been formed during installation or changes to existing damage to the cells due to the stresses of installation. Additionally, by conducting EL early in the project installation phase, you can verify those procedures and training before you've installed an entire project's worth of modules and potentially damaged many megawatts of modules with a poor procedure. For a large project, a periodic EL check can be used to make sure that you have consistent quality across the project and that quality doesn't vary from crew to crew or over the course of that construction period. There are a lot of benefits for including EL during that initial construction phase to help identify damage in a way that you can prevent damage and also reduce the impact of that damage by addressing it earlier on in the process. Additionally, that post-installation testing can serve as a baseline in the event of a severe weather event. As mentioned in the previous panel, more and more insurers are requiring a measurement of what the modules looked like before that weather event so that they can evaluate what damage was new after a weather event. And you can work in an inspection as a post-installation inspection that can serve both as a quality assurance inspection for that installation process and as that baseline that will help you potentially increase the likelihood of having a successful insurance claim. EL imaging is also a great way to identify damage that was done during a storm and that may not be visible to the naked eye, as all the benefits of EL to make it a good field quality assurance tool also make it a good damage detection tool. EL is a really great field tool that can help us as an industry identify module damage in ways that we can reduce the number of modules that are being damaged during installation and understand the condition of the project as it operates. Thank you.
Claire Kearns-McCoy, thank you very much. If you could stand by 1 minute, we have a couple of questions, if you wouldn't mind answering those. One from our audience, and the question is, what amount of modules, how many, would you typically test with EL during both transportation or installation in order for it to be relevant for a possible warranty claim?
Yeah, so we typically recommend selecting sample sizes based on the ISO 2859 standard and selecting the lot for that based on any information that we know about the asset. So that can be different shipment batches might be considered as one lot, or it might be project modules installed by one contractor versus another. It kind of depends on the project specific details.
Mm-hmm. Okay. And another question, is electroluminescence imaging typically used as part of a regular O&M strategy, or is it most effectively used when the performance issues actually are detected?
So what's really powerful about EL is EL can detect issues that are going to cause a problem for the asset owner in the future, but may not currently be causing a problem. And so EL is a really valuable tool anytime you want to get a sense of the condition of the project and understand what might be coming, what risks exist in terms of micro cracks that in their current state might not be detectable during IR or IV curve tracing because they're not currently causing power loss, but have the potential and are likely to open up and develop into more severe cracks that will cause a power loss for the project in the future.
And we have perhaps 30 seconds left just for one more question. If you could just talk a moment about what a benefit cost equation might look like. How is EL best justified by a project owner and operator and the maintenance group? What does that look like? What are the key considerations?
Yeah, so for an EL early in the project, the key benefit there is that if you're able to detect that your installation procedure may be causing damage, it's very worth that to detect that early in the project, especially if you have a large project that might have hundreds of megawatts before you've damaged potentially tens of thousands of modules with your installation procedure. And so that information is quite valuable early on. The other case, as mentioned a little bit, is that post-event testing, in which case, once again, you're able to identify damaged modules and potentially expand the size of your insurance claim through modules that have invisible damage versus modules that just have visible damage.
Very nice. Very nice. Thank you very much. Claire Kearns-McCoy, thank you very much for joining us today. Greatly appreciate your insights. Thank you. In a moment, we'll turn our attention to some of the recent hardware innovations that are having an impact on the North American solar sector. The growing adoption of large format modules has been a major development over the last 18 months or so, but their use is driving a host of design issues and equipment specification options. We'll also be taking a look at quality control monitoring and assurance alongside ongoing issues with cabling mismatches that can have a real impact on solar performance. But first, let's take a look at some of the real-world challenges that the rapidly expanding adoption of large format modules are having. And here to help lead this discussion on large format modules and their impact is Jonathan Gifford, Editor-in-Chief with PV Magazine Global. Hi, Jonathan.
Yeah, hi, David. Thanks very much for having me here today. It's a great pleasure to be with you, and it's been a fantastic event thus far, so that's a credit to you and the PV Magazine USA team. I'm enjoying it thoroughly. Well, we'll kick off this segment with a look at balance of system savings and reliability risks as a result of large format module adoption and insights into directions for future advancements. For this, I'm pleased to introduce Hongbin Fang, the Director of Product Marketing in the US for LONGi. Welcome, Hongbin. Nice to see you again.
Jonathan and David.
Well, fantastic. Welcome to Roundtables USA. Please take it away with your presentation.
Okay. Yeah, I'll focus my presentation on reliability. Right. So first, let me use a few numbers to introduce LONGi. LONGi started in 2000 as a dedicated mono ink and wafer manufacturer, and so for the so by 2020, we shipped more than 58 gigawatt of mono wafers, are the largest mono wafer manufacturer globally, and takes more than 40% of the market share. Since the end of 2014, LONGi expanded into cell and module business. And within 6 years, by 2020, last year, right, we were able to ship 24.5 gigawatts of mono PERC modules globally, became the largest mono module manufacturer. Takes about 19% of the market share. LONGi is also the most bankable solar module brand. And since Q1 of 2020, LONGi is the only AAA rated module manufacturer in this PV module tech bankability rating, right? And LONGi always consider ourselves as a technology company by consistently invest 5 to 7% of our revenue into R&D. So last year alone, we invested about $400 million US. And so this is the most among all PV manufacturers. This consistently elevated R&D investment really helped LONGi to develop product with a leading performance at a lower cost, which in turn enable us to deliver strong financial performance and strong bankability rating. And first, let's look at the reliability. We think reliability is the foundation for realizing lower LCOE. All the innovative technologies need to demonstrate solid reliability performance before high volume manufacturing implementation. If you look at this simplified LCOE equation, the numerator is composed of all the cost, module cost, BOS, and O&M finance cost. And the denominator is composed of energy yield. It's the electricity generated throughout the lifetime of the PV system. What is not, in the last few years, there's all these innovative technologies introduced into the marketplace, help our customers to reduce cost, either the module cost or BOS cost, and also help to improve energy yield. What is not obvious actually in this equation is the reliability. Reliability, plays a critical role to ensure that energy yield that is can be energy yield can be consistent throughout the lifetime of the system. Without this, if either the module or the component is not reliable, the energy yield can be reduced significantly through the lifetime, which the perceived lower LCOE is not realized. So we think the reliability is the foundation for realizing this lower LCOE. So especially in the right now, the PV modules, PV systems are designed to operate, to generate electricity consistently through its lifetime of more than 25 to 30 years, right? And with these, so extreme weathers now become more and more common. So it's very likely, that the PV system may experience some extreme weathers. We need to ensure that we have enough margin in our design that the system can survive through all these extreme weathers and then perform well consistently through its lifetime. So at the LONGi, we take a comprehensive approach on the product quality and reliability. We start from the reliability mindset, start from the module design and material selection. And then, we also use industry-leading technical standards through our process optimization and then reliability testing phase. And for the module production, and we implemented a comprehensive quality management system, as well as the ongoing reliability monitoring program to ensure the produced modules have good quality and reliability. Actually, we do not stop there. And we also actively engage with the third-party labs and then partners, customers, to validate the real-life performance of our product. So here, there are a few major technological innovations adopted in the PV industry that LONGi are leading the way, introduced into the marketplace in the last few years. This chart summarizes mono market share change in the last few years, and together with the few major technological innovations. For example, the multi to mono shift, mono PERC and bifacial PERC adoption, and then also the large format cell and the module M6 and M10 standardization. All these advanced technologies help to help our customer to realize better value of mono technology, which is resulting into massive shift from in the marketplace from multi to mono. Back in 2015, the mono market shares less than 20%. Nowadays, more than 90% of the market is doing mono. Right, and for all these technological innovations, many of these in many places actually do help to improve the reliability. For example, this multi to mono. The mono wafer is more robust material, which can sustain stronger performance through the lifetime of the module of the system. And another example is the bifacial modules made with a double glass construction. Right, I think the extensive third-party tests have extended reliability tests have shown that the double glass bifacial modules, the power degradation through this extended reliability testing are much lower compared to the monofacial glass backsheet construction. In the last couple of years, these large size wafer and then large size modules using large size wafer have been demonstrated as an effective way to help our customer to reduce BOS costs and resulting in the lower LCOE. But however, this is a large size format modules. If the module size cannot keep increasing, larger and larger. And as actually the module size and then power increase become larger and larger, the BOS savings, the incremental BOS savings become smaller and smaller, has reached a plateau. So at this moment, if you look at all the large format modules made with 182 or 210 millimeter wafer and cells, the analysis have shown that there's not much BOS savings between those different modules with a pretty wide power range from 500 up to 660 watt. So basically, the module size cannot keep increasing without compromising on the reliability risk. The larger format, the ever increasing size on the module will bring up the reliability risk higher. One example is that all the bifacial modules are made with the 2 millimeter plus 2 millimeter glass. There's no support in between the two long frames. So you can imagine when the module size 182.72, the width of the module is about 1.1 meter. And then the 210 60 cell and 66 cell modules are 1.3 meters. Under the same load,
I need to interrupt, if you don't mind. I'm sorry. We can continue with that discussion, but we want to have the full panel join us as well for the discussion. And I'll invite you to stay with us as we move into this larger panel discussion with your consideration. I greatly appreciate it.
Indeed, thanks Hongbin. And we're going to look deeper into these larger format modules and some of the structural challenges that they face, so do stick around for that. And it's been difficult to look past the emergence of large format modules into global PV markets throughout this year, 400, 500, and even 600 watt plus modules. But as with the concerns we've been hearing about earlier about severe weather and even extreme weather events, there's increasing discussions about the implications for large format module performance over the long term. Concerns are being raised about these new big modules, as we've just heard, in terms of a number of key considerations: wind loads, module currents, and even weight.
Our panelists to discuss these issues have three very different areas of expertise. Hongbin Fang is the Director of Product Marketing at Endurans Solar, who we've heard from just a few minutes ago. Pedro Magalhães is the Director of Global Engineering and R&D at Arctech Solar. And Ben Damiani is the CTO and Co-Founder of Solar Inventions. Welcome to all of you. And just as a reminder to our live audience, please send through your questions and join in our discussion today. Jonathan.
Yeah, thanks very much, David, and welcome, gentlemen. Thanks for being a part of this discussion. Pedro, I'll come to you straight away. As a tracker supplier, can you give us some kind of indication in terms of market penetration of these large format modules that you're seeing in US projects that you're supplying today?
Sure. So in the US, what we're seeing is like 85% of the projects, at least our projects, utility scale projects, use modules that are like 500 watts plus. We have like about 15% of projects with the old dish, I'd say 400 watt panels. Worldwide, in our utility scale projects, pretty much every single one of them is using already modules that are larger than 500 watts.
Okay, and when you're talking about dimensions then, for a tracker supplier, the physical dimensions are a key component and a key part of the equation. What kind of dimensions are you seeing most commonly?
Right, so in terms of dimensions, you know that these large modules are governed by cell size. And, we have like these two different cells, 182 and 210 millimeters. So modules that use 182 millimeter cells, we're seeing typically two sizes, 1.1 by 2.2 meters, and then 1.1 by 2.4. That's for 182 cells. On the 210 cells, these M12s, we are seeing 1.1 by 2.4, 1.3 by 2.1, and 1.3 by 2.4. So I'd say that in the US, we have not been asked to study any projects with this super large 1.3 by 2.4. We've seen only projects with 182 millimeter cells in the US. But in other parts of the world, I'd say that we've seen probably 80% of 182 cells and 20% of 210 cells.
Okay, and then as a tracker supplier, just the last question in this section, how are you responding then to the challenge of these larger dimensions?
Right, so these larger modules increase both tracker dimensions, if you will. I'm talking about cord and length, and that has like structural impact, mainly instability or stability impact on our trackers and our structure. Traditional flexible trackers, which are the type of trackers that people are used to, had to reduce tracker length to cope with these new panels. So a lot of manufacturers that insisted on, traditional trackers moved on to dual row trackers. That's basically two rows connected together by a central mechanism. Other manufacturers, and the Arctech is on these other manufacturers' pool, if you will, decided to move on to innovative trackers that are of a rigid construction. We use more fixed points, along the torque tube. So we make a very, very rigid tracker. And that allows us to stow the tracker at 0 instead of 30, and have way larger stability because deflections are smaller.
Okay, well, and wind deflections, then I think we're going to address that in more detail, and the wind shear effects also throughout this discussion today. Ben Damiani from Solar Inventions, I'd like to bring you into the discussion here. So Pedro's talked about some of the structural challenges posed by these larger formats. What would you then say about some of the impacts that these wind forces or these additional forces may have on the interior of the module, or the active, productive parts?
Sure. As you go larger, you're going to have greater impact, greater flexing, and with a typical module, you're composed of the silicon layer, the EVA, the solder joints, and the frame and the glass. And each one of those has a different modulus for how it deflects. And so as you get larger, the stress that can come into it, of course, is going to be increased, going out from the wafer size being larger. So some of the ideas on how to address this is to maybe go to thicker glass for both sides of the panel, as well as multi-wire certainly helps. And potentially thicker wafers or how you go, or a stronger frame. You also have longer wires depending on your path length from the module itself. So the current travels through the module and then of course comes out through the wires, and all of those factors don't always contribute to the overall higher efficiency with the panel in operation, based on you might have a higher power panel coming off of the production line as you test it in standard conditions, but that might not be fully realized when you do your installation based on what you do. And for the longer length or higher temperature, that the thicker glass could potentially modestly approach or modestly influence, not drastic, but something on the order of maybe 1 degree Celsius.
Yeah, okay, and thicker glass or beefing up the module rail will also have implications when it comes to weight, and then Pedro has to deal with a whole new set of problems on the tracker front. But let's talk about what potential impacts could happen in terms of damage within the module. What have you seen, or what can you foresee?
Certainly more cracking as you go with a larger wafer size. And I think we saw earlier in your presentation, this roundtable, for the electroluminescence imaging that can highlight some of these impacts. And certainly within time, you're going to generate, with more flex in the panel, you're going to generate more cracks. The other part of this that comes in with the higher efficiency, or with looking at a larger wafer, when you get more cracks, then you're going to generate more hot points or hot spots, and just the overall integrity of the panel.
Okay, well, Hongbin, thank you for waiting patiently at this early stage of the discussion. I think you mentioned the figure 400 million in annual R&D spend from LONGi. What's your R&D telling you then? How does that align to some of the issues that both Ben and Pedro have raised in terms of larger format modules?
Yeah, I think this is, we have spent a lot of effort when we design these large format modules, right? We have foreseen that definitely, as I showed in my last slide, that when we, 182 72 cell module have a width of 1.1 meter, and the 210 6-row design has a 1.3 meters. When we doing the mechanical loading test, right, under the same load, you realize we found out that the larger format, the 1.3 meter modules showed 40 to 60% higher deformation at the middle of the module, right? Which is going to increase the chance for micro cracking. We have seen that during the test, and also for potential for glass breakage. So these are the issues that we have seen during the testing. The other testing is like a dynamic mechanical loading testing. You will see that with the the modules are held by 4 contact point on the tracker. Right, under the same load, under the same pressure, you will see a higher shear stress, at the 4 contact point, which result in faster fatigue at the contact point. which result into, potentially can result into frame tearing. So this is I think so we have spent a lot of effort to study these. That's why we think the module cannot go infinitely larger without increasing, without compromising on the reliability performance.
Yeah, okay. Well, and what about some of the potential solutions on the module level then? What about things like thicker glass? Jenya Meydbray from PVEL earlier was saying that quite contrary of that, glass is getting thinner and thinner. What about multi-bus bar in terms of mitigating some of these effects? How effective do you think they are, Hongbin?
Yeah, the multi-bus bar is already implemented, right? But the thicker glass, I think, has the same implications. It will increase the weight. Well, and right now, the module is already close to, the 600 watt module is already close to 35 kilos, right? So with a thicker glass, you can increase both the weight and also the cost of the module as well, right? Which, we have analyzed that the larger, if you increase getting the module size even larger, higher power, really does not improve on the BOS cost. If the module cost is higher, you end up with a probably higher system cost. In that case, what's the benefit, right? So why do we want to go that route? So we actually think we probably need to stop somewhere here, right? What do we have here? LONGi will stop at the 182/72 cell. We're not going to make modules larger than this format. Instead, we'll focus on the cell and the module efficiency improvement, right? Which can really bring better value for, to reduce the BOS cost as well as the LCOE.
Okay, well, cell efficiencies are not the easiest things to boost in terms of the limit we've more or less reached with PERC technology, but it's encouraging to see a kind of doubling down of effort there. David, in terms of our attendees today, are we getting some questions through?
We are getting some questions indeed, and I wanted to kind of stay with Hongbin for a minute and look a little bit more in depth on performance issues and the performance drops over the life of a module. What are you seeing? What can be expected? And perhaps Ben can chime in on this as well. But can you speak a little bit more expansively on the performance issue?
The performance-wise, basically, I think we have to go through. The industry has developed a pretty sophisticated and well-developed the reliability testing to ensure the modules, the systems are compatible and also can sustain, pretty extended period of performance, right? So I think with the advancement in the latest technology on the PERC, monofacial PERC and bifacial PERC, that, the degradation mechanism has been minimized. And so the overall, I think the performance is improving, right? And so, but we have to watch out for these larger format modules to make sure, the module design are adequate and also are tested, right? The performance, during the production, the quality and reliability are verified, right? So that the field, so the module when module installed in the field, the performance can be consistent.
Okay, and Ben, do you have something that you'd like to add to that? What kind of degradation could potential cell cracking as a result of these wins or this additional deflection that's going to occur in the larger formats potentially? What kind of degradation could take place?
Sure. With the solar panel, I think we are all familiar that the performance of the panel can only go as fast as the lead dog or the slowest dog, actually. And so when you have a cracking event inside of a cell, it's going to impact the string that it's in. And that could be bird dropping or shadowing. And so as you go to these larger and larger formats, what that means is each string represents, depending on if it's a half cell or a whole cell, you might have, if you have a 600 watt panel, then each 600 watt panel that's half cell would have 100 watts to 200 watts that it would have for each shading event. So when you had some sort of damage, then you would lose a bigger chunk of power by going to a larger and larger format. So that's one concern that I would have. Same impact with edge shadowing. And then I think even at the cell side, one thing that's going to be interesting, and maybe Hongbin can comment on this, as you go to larger and larger cell formats, initially the wafer thickness is a little increased for processing, and that could also influence the degradation within the wafer. You want the thinner wafer to minimize those impacts of degradation for light-induced degradation in particular. But if you go to a thinner wafer, that's also going to amplify your exposure to the stress of the shear force for the larger format. So it's a tricky question, and something we certainly have to look out for.
Yeah, kind of a balancing act, I suppose, in terms of the wafer thickness there. Hongbin, did you want to come on the back of that in terms of, you know, what kind of, how to strike that balance with larger wafers and larger formats and wafer thickness and potential LID degradation?
Yeah, definitely. I think the wafer thickness is also on the, you know, it's progressively getting thinner and thinner, right? As we, you know, need to improve on the cost, and also, you know, but every step when we reduce the wafer thickness, all these mechanical stability, electrical, you know, performance are verified, right? To ensure, you know, the reliability performance is not compromised. So definitely we need to verify, and that has been, I think the whole industry has been doing pretty well in terms of verify the performance to make sure, you know, the reliability performance, the degradation is not compromised.
Okay, well, thank you. We're talking a lot about the module and the cell. Pedro, I want to bring you back into the discussion here from Arctech Trackers. We heard earlier when we were addressing kind of extreme or severe weather events, the importance of kind of a system level approach, particularly when it comes to larger formats. I think Jenya used the phrase that some of these modules are like a sail out there catching the wind, which is not particularly a challenge that any tracker manufacturer would like to face. What kind of role then is stow strategies in terms of dealing with potentially severe winds or stronger winds coming in when you do have larger modules in place?
Right. So when I talk about this topic, I typically talk about the module tracker paradox. You know, with the traditional tracker, what's good for the tracker is bad for the module, and vice versa. You know, for traditional trackers that are very flexible to actually resist wind loading, they you know, need to stow at a steep angle. And that increases the pressure onto the module surface by a lot. So as we see modules growing and growing in size, you know, we're not going to be able to put those modules, you know, in steep angles towards the wind anymore. So these modules require stow at 0 degrees, right? And you can only stow at 0 degrees if you change the way of doing trackers. And that's where these new rigid trackers come in. So the winning solution, I would say, the only reliable solution from now on is to pair these large modules with rigid trackers, because traditional flexible trackers don't cut it anymore.
Well, if you are stowing at 0 degrees, then naturally there's a trade-off when it comes to power output, right? If kind of storm season, I can see power output dropping off. Is that right?
I don't think so. Actually, there are no trade-offs. The only reason why people, why trackers were not stowing at 0 was because it was not safe for the tracker. The tracker was too flexible, and if you stow at 0, you get into you know, divergence very, very quickly. So trackers couldn't just do it because they used to be inherently flexible structures. So stowing at 0 only brings benefits because the pressure on the panel is lower. Consequently, the pressure that you have to cope designing tracker components is also lower. And when the storm comes, most of the light is diffuse. And the best way to collect diffuse light is actually to look at the whole sky. And you look at the whole sky when you are at 0. If you stow at 45 degrees, let's say, you have like half of the sky on your back. So stowing at 0 increases production, does not decrease production.
And we're talking about bifacial modules as well, quite clearly here.
Right. We're talking about both monofacial and bifacial. Bear in mind, again, if we are talking about a high wind event, that's typically associated with clouds or a storm of some sort. So direct sunlight is reduced, and the biggest chunk of your source comes from diffuse light. And like I said, the best way of collecting diffuse light is when you are at 0 degrees. Okay, so there are two takeaways that are very important here. You want to use large format modules. You need to control the pressure that gets to those modules, because as both dimensions increase, those modules will not be able to get high pressures. And then two, it's better for your energy production because you're seeing more of the sky, which means that you're collecting more diffuse light.
Yeah, and with high winds generally come storms, and that means cloud cover and diffuse light. Right. Okay, well, we've talked about wind shear, we've talked about right inside the cell, cracking, even wafer thickness, but let's look at module currents. With some of these larger format modules or very large format modules, we're talking about higher currents. I suppose, Ben, I'll go to you first. What kind of reliability issues do you see with higher module currents at the system level, I suppose?
So, I squared R losses. So you have the square of the current times the resistance is what your power loss is going to be. So the change in the wafer format has been pretty dramatic in the last 18 months. And as it turns out, as you go to these larger format wafers, especially up to the M12 size, then when you cut that in half, you're back to the size of a current whole wafer of like M2. So you kind of lose some of the benefit potentially there of the half-cut cell, unless you compare it to itself. Of course, having 17 or 18 amps on a wafer would be prohibitive, and you would lose like 30 watts of power in a panel if you didn't cut that in half. So it becomes very imperative. So that's a big concern. So it mandates that you go to half cell on that larger format size.
Okay, well, that's inside the module. Pedro, what about from a BOS perspective? Naturally, at Arctech, you work with some of the EBOS, the electrical balance of systems suppliers as well. Do you think there's challenges that you're seeing in the field with higher module currents?
Right. So we are associated to the BOS choices that are made in plant design. We are not necessarily supplying electrical BOS components, but we have seen that previous EBOS components that have been designed for certain amps don't work anymore. Right? We used to combine strings and get higher currents, and we used to have like 20 amp fuses, 30 amp fuses in these 210 cell modules. We are stringing those modules in 35 modules per string, 38 modules per string. One or two projects even at 40 modules per string, and we have huge currents and lower voltages. So those fuses, all those gauges that we used to see, in the EBOS side now, were pretty much all redesigned. So that was big impact as well. I would say.
Yeah, okay. Well, we've been talking primarily about, well, actually exclusively about the utility scale, I suppose, up until this point. But Ben, you work a lot in the CNI space as well. And of course, this is a huge market in the US. Not only in the US, in so many parts of the world. Solar in the rooftop just makes sense. What kind of implications do you see for larger modules, particularly as it pertains to current up on the rooftop?
Particularly as it pertains to current, we would much prefer from an electrical performance standpoint, higher voltage, lower current just means less loss. And in the CNI space, you're going to have some additional challenges with the larger size format as well. We get questions about, people will walk on the panel in residential type applications to blow leaves off the roof or however it might be, and handling a large size format can get challenging if you're putting in a solar canopy. So to stretch out and handle that. And then there's the weight concerns. So there's some challenges we're adjusting to. The bigger power is good at the surface, but can be more problematic when issues come in. So it, still most of the commercial size spaces that we're using will have the installations with the smaller format, the M6, still at this time.
Okay. But I imagine that, the transition to higher powered modules, larger format modules will be an ongoing one. So we've seen supply of, these smaller wafers really pretty much dry up. So there will be more challenges for rooftop installers also to face. Hongbin, I'll let you round out this panel discussion today. You've got a very clear message for the market in terms of what LONGi believes is this optimal size. How are people reacting to this message? How well do you think is the understanding in the market about some of these challenges that you're setting out?
I think many of customers have, realized all these challenges, all these reliability concerns and risks. I think this is, the market is getting there. And for example, in China, for the bidding, there's a pretty high percentage of the bidding process. They eliminate, they prevent high current modules from, being qualified for those, projects. Right, so many of customers have realized, but I think we basically need to have more discussions and also more, probably a field performance validations to understand, so that people get real life examples. And I hope, people don't learn in the hard way that, a few years down the road that you'll see pretty significant energy yield drop from your system. That's a result because of inadequate, testing, verification, or just some intrinsic, issues with oversized modules, right? What we really concern is this oversized that spans 1.3 meters, and that's, mechanically just not strong enough to be, supported by this 2+2 millimeter glass. And so we hope, basically, on the other hand, the BOS cost analysis have indicated that there's not much difference among all these different large size modules. So with the kind of the same BOS, similar BOS savings, but the reliability risk jumps up with the module size increasing much larger. And so that's something we totally against. And so we will focus on the cell and the module efficiency improvement for the next generation technology, so that really can bring better value for the customers.
Well, thank you, Jonathan, for leading that interesting discussion. And our thanks also to Hongbin Fang from LONGi, Pedro Magalhães from Arctech Solar, and Ben Damiani from Solar Inventions. We're going to change the pace just a little bit and have a fireside chat on performance issues that are cropping up across the solar PV value chain. Welcome back, Tim.
Thank you very much, David. In particular, we'll now focus on DC cabling mismatch issues that can lead to underperformance regardless of format type. And we'll also talk about some of the latest techniques in quality control monitoring and assurance, as well as the interesting dynamic of quality specifications in purchase agreements. Joining us at the Fireside Chat are Frederick Dross, Vice President of Strategic Development for Synergy Technical Services, or as we like to call them, STS, and Brian Mills, Head of Alternative Energy in North America for Stoibli Electric Connectors. Welcome to you both.
Good to be with you. Thank you.
Hi, gentlemen. Thank you for joining us today. Much appreciated. Brian, I'd like to begin with you, if we could. Could you quickly help us understand the nature of the connector issue, how common it is, and its broad implications?
Oh, yeah, certainly. So in the industry at large, actually, and this is information that comes from third-party sources, not just from companies like Stoibli, but actually TUV, the European Bankability PV project. What you'll find in most of their analysis is that if you look at not just the number of occurrences, but the severity of occurrences in PV systems, they're all centered around either the connector, the cabling, both the product and the practices. And so obviously it's a key issue to be concerned with. And that can come about from a myriad of different reasons. When you look at it holistically, what you're concerned with are two major factors. Do you have a growth or an increase in contact resistance or electrical resistance in the connection that will lead to power losses, overheating, fire, or do you have compromised installation on the connector or the cabling, which can lead to arc failures? And there's a whole host of different reasons why these things can come up, but for the most part, it can be contributed to either poor selection of product, incorrect handling of the product or implementation of the product. And when you look at the overall cost of this portion, the electrical balance of systems portions for a installation, commercial, residential, utility scale, the connectors and cabling comprise less than 1% of the actual budget, and yet they can be the leading cause of issues in the field and catastrophic failure of the system.
And why is there such a large disparity in common fault timelines? In other words, why are some right after the project's COD and some don't occur until years down the line?
Yeah, that's an interesting paradigm. So what we've noticed is you either see those failures almost immediately. So it's such a large issue. Some of the main things that we see that cause almost immediate failure is like if you have compromised the cabling jacket, you've severed it in the way you've harnessed it to the racking system. You've improperly assembled the connector to the cable. You've chose the wrong cable connector combination. Also very common, you've cross-mated connectors. So you have connectors from two different manufacturers that were never designed to actually be plugged together, but they look exactly the same. And for various reasons, one competitor thought it would be smart to make one that looks and acts just like the other competitors. So they allow them to be plugged together. And eventually this causes an issue. So what we see typically is you have an egregious issue that shows up right away in the first couple months, or you have what I like to call a ticking time bomb. It's a small issue that allows for the growth of resistance over time. And typically those start to manifest themselves at the 3 to 5 year point. So either you have an immediate failure that shows its ugly head right away, or the system seems to be okay for a couple years, and then the problems start to show up. And it is that interesting 3 to 5 year bandwidth where we start to see field failures due to cross-mating, due to a compromised or improper assembly practice, or however the cabling connectors were actually constrained in the system can impart a lot of damage. So yeah, in general, strangely enough, it's either within the first couple months or typically in that 3 to 5 year range.
Mm-hmm. I'd like you to address both issues related to workplace practices and also industry standards. What role do those factors play in addressing the connector issue? Could you address both of those?
Sure. So one of the things I think that's not really understood in the industry, because we talk about product that's certified, and maybe the connector product itself or the packaging it came in has the certification mark on it. One might think, well, that's the certified product. The truth is actually what's certified is that product and the exact cabling combinations that product was submitted to the certification agency with, the specific tooling that was prescribed for crimping the connection, assembling the product, and the practices that are used to implement the product into the field according to an assembly instructions that's supplied by the manufacturer. That system is actually what's certified. So if you deviate from that system, then what you're doing is you're in the unknown. You're operating in a way that was never certified by the certification agency, but also never validated by the manufacturer. So if you use the wrong crimp tool to crimp the cable to the connector, if you use the wrong size cable with the connector, if you put it in the field and you put stresses on the connector that it wasn't designed to handle because you didn't really pay attention to the assembly instructions or the installation manual, these are all things that, unbeknownst to the installer or the user, might seem like benign things, but they actually can severely degrade the performance or compromise the performance of the product. And again, the certification agencies are operating on the understanding that this is what I'm supplying to you to certify. So what is certified isn't always what ends up in the field. And so you can't always rely on the certification in that situation to be the gold stamp of quality and performance and safety in the field, because if you're not maintaining that system from procurement, process, implementation, then what you end up with is not actually a certified product anymore. And so again, what we see very commonly in the field is crimp connections that are done with the wrong crimp tool, the mismatch of cable to the correct connector, not tightening the cable gland properly, not having a good seal to protect the interconnection. You have two major points inside the connector that can cause a failure. You have the crimp connection on each side of the mated pair, and then you have the interconnection that happens between the socket and the plug. And so there are all these mechanisms in place and procedures in place to create a good, competent connection, but also to protect it. And so all of those steps, all of those tools, all those procedures are meant to get you to an endpoint where what you've made is what's expected to be put into the field and what has been certified, verified, and eventually is warranted to be used in the field.
And as a key takeaway, if the idea is to minimize any sort of disruption before it can ever happen, what are the key takeaways in terms of how potential causes can be identified before they ever evolve into a performance affecting issue? What are the key points that you'd like to get across there?
I think probably it all starts in the very beginning of the project when you're at the procurement stage and the engineering and design stage. It's really important to do the background work, the homework to make sure that you're using consistently quality product from the same supplier, that you have made sure to specify the right cable and connector combination. In other words, that cable is part of the certification of that connector, that the company is actually going to warranty and certify the use of that cable with those connectors. And then really what's I've found to be lacking in the industry these days is really thorough and comprehensive best practices around cabling and connectors, especially at the utility scale where realistically, when you think about how most installers operate, they're very consistent. You know, they have a methodology they like to use. And so when they do a connection, when they do a cable constraint to a racking member or something like this, they do it basically the same way through the entire system. And a lot of times what they're aiming for is what looks nice and neat. And unfortunately, sometimes what looks nice and neat might not be the best solution for the long-term survivability of the products and how you're putting them into place. So I think what would really serve the industry most these days is really focusing on best practices, making sure that what's going out into the field, what's being installed, what's being commissioned is consistently the best that it can be, so that you can head off any of those costs down the road, any of those failures down the road that are going to eat into your energy production, eat into your profit from a utility scale system, and more importantly, keep from, you know, large damage events and fires, structural damage from ever happening.
Very good. Good. Thanks, Brian. Frederick Drost from STS, I'd like to bring you into the discussion now. And I wonder if you could discuss for us what some of the shortcomings are in quality assurance that can lead to such high rates of defective operation.
Yeah, thank you. So, well, we've heard this morning a lot about the problems that arrive in the field due to weather event, for instance, due to some external factors, due to the environment, whether it's the wind, whether it's the hail, whether it's the sun. But actually, there are a lot of things that are happening in production, during manufacturing, that can have a detrimental effect on the performance of the assets. You know, I think it's important to note that it's much more valuable, it's much more cost effective to capture these issues as early as possible, and as early as possible means directly in the manufacturing, at the manufacturing site. And if you want, I can just give you an example, a recent example, because you know, we just like some of the speakers that you had previously, we are offering solutions for you know, electroluminescence in the field or any other type of field inspection. Also, you know. Construction monitoring. So during the construction of the panels of the plant itself, and recently we've been pulled in a project where there was some degradation. So the developer was experiencing some degradation in the field, and they are ready to do some inspections, a very serious inspection, you know, hundreds of thousands of dollars of inspection every year, just to evaluate the the degradation that they have, not even to fix it, but just to evaluate the degradation that they have every year. And then, okay, we came into this this project, and then we looked at the images, the EL images that were taken in the factory, and we realized that they were full of manufacturing defects. And these are the manufacturing defects actually which are pulling the performance down. So instead of spending hundreds of thousands of dollars every year just to monitor, not even to fix, but just to monitor, you could have totally avoided that by having a better quality control plan or a better inspection test plan in the factory.
And I wonder, just following up on that a little bit, to what extent do you think this is an issue of improper manufacturing quality standards or inadequate product testing?
So I think it's a little bit of both. You have two things to consider when you're looking at inspection in the factory. You have what is called the quality control plan, which is basically the criteria that I used to evaluate whether the module is a pass or is a fail. And then you have the inspection and test plan. And these are the tests that you're doing to verify the conformity to the criteria. And just if we take one example, safety tests are typically done at the end of a line. So you can, for instance, not test at all for safety tests. You can avoid doing wet leakage in the factory, and that you will have an additional risk in the field that some of the modules may not be compliant to some of the safety features. Or you can say, okay, I'm going to do some safety tests, but I'm going to allow to have maybe 1% defective or 5% defective even. Or you can say, no, I want absolutely zero defects. And for instance, we've had indeed some, as we were entering into a discussion and negotiation with a client, we've had some manufacturer putting forward that they wanted to perform these tests, but allow some critical defect, up to 1% critical defect in the lot that they were going to ship. So you can imagine 300 megawatt project, 1% of that is 3 megawatts that could potentially have critical defect, including safety hazards.
I wonder if you could briefly offer a few ideas around what advancements need to be made in order to ensure more consistent quality practices in manufacturing. Just briefly, a few key points that we should consider.
Sure. Mm-hmm. Yeah, I think the tools are there. There are tools that exist. In 2018 already, we have developed a standard. And just like any IEC 61215 or 61730 standard can be put directly into the purchase agreements, the standard that we have is for approval of manufacturing and dispatch of PV modules, and it can be directly inserted into the contract agreement, and that will protect you. So simply having this standard included into the purchase agreement is an excellent step. And by the way, up to now, we were offering this standard for a price tag, but we think it's time now for more people to benefit from it. So we are actually starting to offer it for free, starting today, in fact.
Very good. Tim, do you have a question from the audience for Brian and Frederick?
Yeah, just one here, and I believe it was directed at you, Brian. You brought up earlier that a common failure occurrence is mismatching with cables or connectors that may seem to be pairable, but obviously, if they're leading to issues, are not, and that immediately kind of brings up the idea of standardization. Now, is this an issue that there should be a standard size, a standard connection available, or should it go the opposite way, where it should be very clear that this connector goes with, these connections are to be made and they are not to be mixed?
That's it's a popular question these days. What we have found for sure in today's market is if you choose quality connectors, you put them together properly, you put them into the field properly, you don't see issues over the life of the product. So the idea that just creating a standardized connector is going to fix things, unfortunately, I think that alone in a vacuum would not be the right solution, because even if you take a standardized connector, you put it together wrong in the field, you still have an issue. And then actually you have a different level of issue that the standardized connector product is going to still needs to grapple with. You know, there's some industry move right now to try to, there has been for, you know, literally decades now, different organizations, different consortiums, different groups that have tried to figure out a standardized connector format. And one of the big things that you have to grapple with is, once you do that, now what you're putting into the field is a plurality of different suppliers of connectors. And so when an issue happens in the field today, you know, you have to take a step back and understand what level of severity of issue we're talking about here in terms of how much power is at these connectors. I like to use the analogy of the typical American home gets energy off of the grid coming in at 220 volts, usually a 200 amp service. So 44 kW of 220 AC energy. In a utility scale application, 1500 volt, 30 amp connection attached to 10 gauge wire, 45 kW of 1500 volt DC energy. All the power that would be needed to power your home is passing through this connection, and it's a DC format at 1500 volts, very dangerous. It can self-propagate an arc across the failed joint for up to 6, 8, even 10 inches, depending on the condition. So when you have a failure in the field, what was the failure disappears, typically. All that's left is a couple charred cables. So what you do is you look elsewhere in the system, you try to figure out what could have gone wrong. In today's market, when you look around the system, you see the same manufacturer's connectors elsewhere in the system plugged together. You can say, all right, well, were they put together properly? Was the right cable used with them? Were they assembled into the installation incorrectly? You can look for some extenuating circumstances, some ancillary evidence of what might have happened at that burnt connection. In a standardized connector situation, now you're looking at a bunch of different products from different manufacturers, and you can't draw a lot of the same conclusions. So what paradigm that creates is the need for then the equipment manufacturer, the OEM equipment manufacturer, to become responsible for the connections, because they're entering into a market where there's a plurality of connections throughout the whole system. You can't say it's one connector company's issue anymore. So unfortunately, just doing a standardized connector actually can exacerbate the situation if you're not addressing all of the real issues that are happening, which is improper installation practices, not paying attention to what crimp tools need to be used, what assembly processes need to be used, and so forth.
Thank you very much,
yeah,
Brian. We're running a bit tight on time here, so I'm going to have to stop you there. But thank you to both Brian and Frederick for joining our Fireside Chat today. As we said to start, weather usually gets the shine in conversations about failure rates, so it's interesting to gain perspective on some other relevant factors here. In just a little bit, you'll be able to join our networking session, visit our expo, and take advantage of our one-on-one instant networking. Leading us into the networking session, we're going to take a few minutes here to explore the expanding role of software as an optimization tool.
Solar that's often paired with energy storage increasingly is being used as a dispatchable resource. Using solar this way will be a key part of efforts to decarbonize power grids and more fully rely on solar for a range of ancillary grid services. It also means that solar performance needs to be maximized in order to deliver expected results. With us to discuss the growing use of machine learning, artificial intelligence, and software applications to enhance solar performance are Aron Dobos, Director of Software Product Management at Nextracker, and Matt Campbell, CEO and Co-Founder of Terabase. Welcome to Aron and Matt.
Thank you.
Hi, everyone. Thanks for having us.
Of course. Matt, I'm going to direct this first question at you, and Aron, please feel free to comment on it afterwards. Could you highlight one or two key factors in conventional project planning, pre-planning, and development that can lead to system underperformance?
Yeah, I think some of the causes that could lead to underperformance would start with the assumptions going into the performance modeling. That could be the weather data, that could be the OND, the PAN file on the equipment. It could be into other system level losses, soiling, snow losses. So it's really about the assumptions used as the basis for the model. I think that's one of the reasons that we see some underperformance. And then the second factor that I would see is perhaps a disconnect between what was actually built and what was modeled. And part of that results from the simplification that goes into the performance modeling. So for example, a lot of performance modeling is done in 2 dimensions. It doesn't take into account the impact of topography. So I think those are a couple of the factors that could have an impact.
Yeah, I would agree with that, everything that Matt said. One of the things that we've seen a lot is that sites aren't being built on flat land, and terrain loss is a particularly substantial gap that's hard to fix between modeling with currently available tools and the as-built real-world performance of these systems. In many cases, the gap is on the order of several percent. And is it really a question of, is the system underperforming, or do we just have the wrong assumptions and the wrong expectation of what that system should actually do? So I think it's important to think about underperformance in the light of what is the expectation and whose expectation that is of the performance, and use the best available modeling tools in enough detail to model the as-built system.
Transitioning now from underperformance to maybe some tools that can enhance performance. Aron, I'd like to address this first to you, and then Matt. What are the primary types of software tools currently available that can enhance performance?
Great question. There's so many tools out there, and so many companies delivering new and advanced software solutions to try to maximize performance. I would think about these in 2 different categories. One, there's the sort of asset management type software that sort of sits on top of conventional monitoring systems, types of advanced analytics software that dig through the SCADA data, the operational time series data from operating plants, identify losses, and can help make recommendations to O&M teams and asset managers on where the actual losses are occurring in the plant and what mitigative actions can be taken to increase performance. The second category of performance enhancing solutions from a software perspective, I think, are really relevant in the tracker world. Of course, at Nextracker, this is something that we're particularly interested in. Advanced tracking algorithms that can adjust in an intelligent way for topography and construction variances between rows can really help unlock additional performance that's really hard to model upfront. Row-to-row shading, diffuse light performance, and it's not just shade avoidance when it comes to row-to-row system performance. Taking into account the architecture and the type of module that you have, split cell modules or half-cut modules have a different response to shading, and having an intelligent software control algorithm that balances angle of incidence losses with shading losses can maximize the performance of the system. This is a technology that we at Nextracker at least call our split boost system.
Definitely. Matt, anything to add there?
No, I think the other element of performance is really determined during the design and development phase, and that's where we see an emerging category of software that we develop as well as other companies, which enables a developer to take a piece of land and look for the optimal solution. And the optimization could be a function of getting more energy, getting a lower cost, or getting a more sort of optimal configuration. And I think we've seen a lot of progress in this field for the last couple of years. And I think in the future, we're just going to see more of it, because a lot of the work that needs to be done to optimize a plant's economics becomes pretty complex and computationally intensive, which lends itself to a modern software-based solution.
Absolutely. I like how you say you're always pursuing greater optimization, because to me it does seem like optimizing is a pursuit rather than a concrete thing that happens. And as we all know, software products can result in some issues of their own where they intend to fix a problem, and maybe they do, but along the lines, another problem shows up. Could you describe, go into detail on some of the issues that can arrive from software, Matt, and then Aron, you may follow up after?
Yeah, I mean, I think software is only as good as the people that use it, and so it's sort of the garbage in, garbage out paradigm, and so that goes back to the earlier point, which is if the basis of your assumptions are wrong, the output isn't going to be correct, and we see sometimes there's a financial motivation to be aggressive in the assumptions used in the modeling because a developer has a short-term perspective on getting into the asset and out of the asset. So that could be things like, the albedo, the bifacial assumptions, the pan file. So I think those can lead to shortcomings in the modeling. I also think that a lot of the commonly used tools, whether it be in performance modeling or CAD design, are a little bit limited in the sort of the modern software capability they can bring. And that's why we think the future is really about, cloud-based architecture where you've got a set of services. They could be design modules, performance modules, cost modules, and these services are interconnected and take advantage of the computational power that cloud computing gives you, so that, some of the limitations imposed by the computing power of a client's desktop could be sort of supercharged by going into the cloud and being able to talk to other services.
Absolutely. Aron?
Yeah, I'll, on the post-construction side of the world, how do you really know how systems are performing? And software that isn't sufficiently intelligent, that's really sort of basic monitoring software, and can introduce a lot of challenges and issues by itself. A mountain of alarms is not useful for anyone. It doesn't help pinpoint problems. So having software that is really domain tailored to the solar domain and is sensitive to the real world issues that solar power plants see in the field can actually be much more useful than sort of conventional monitoring software that may just inundate an operator with noise. And so I think it's important to select software that helps reduce that O&M cost and help pinpoint issues, speaking to the whole, the life cycle of the plant and the 25-year operation life that people are expecting.
Now, Matt, we've spoken about this, and I know you've spoken to our colleague, Ryan Kennedy, kind of extensively about this. But I wanted to kind of pick your mind for a second on one of the specific shortcomings of software right now is that it is used by the customer to optimize their project, to plan their project. The customer builds their project, they run into whatever issues, they run into whatever successes, big bang boom, project gets built, and then the next customer uses that software without kind of the feedback of what worked and what didn't. So I kind of wanted to ask you, what kind of value could be presented by an open, cloud-based, and communicative software planning where, if someone's developing in a similar situation to someone else, they could say, hey, we had this issue with terrain, we had this issue here and there.
Yeah. I mean, for us, I think the big thing is about closing the loop, right? Because we've got a 25 or I like to think 40-year life cycle on these assets, from the early project development through pre-construction, construction, commissioning, and operation. And part of the issue in sort of our disconnected client server-based world of software and solar is that the things don't talk to each other. And when you've got problems on the operational side, they don't necessarily feed back into the beginning of the planning process. And that's where we think having, sort of an integrated software approach that closes a loop, taking feedback on actual construction costs, on actual system performance, and then, using that as like sort of a learning loop to the front end. We think that's really important. I mean, I think in the industry, even though we've been at it for 20 years in the United States, as an example, things like construction costs are a mystery, right? Like it's really hard to understand if I, for example, if I grade the site, is that the economically rational thing to do or not? And part of the reason is we don't collect real data and bring it back to the planning phase. And so I think that's where integrated cloud lifecycle can bring a lot of value in the future.
Gentlemen, we're starting to get a little bit tight on time, so I'm going to cut to our last couple of questions here. And I would like to start with you, Aron. What are currently some examples of data not present in popular software that can improve performance and help solve kind of the model versus reality issue?
Sure. So coming back to where I started, I think terrain is one of the biggest gaps. Modeling the physical layout of the system is technically possible right now with off-the-shelf tools, but that doesn't mean it's easy. And the people running these models, independent engineers, need to invest time and effort to do it correctly. And so sometimes there just isn't room in the budget or motivation to do it because projects can still get built, but ultimately that's one of the key things that we've seen in our experience that leads to a gap between reality and what's expected. I think as more and more products come on the market, different solutions for handling terrain, questions like, does it make sense to cut and fill or and grade a site, or does it make sense rather to pay a little bit more for a different kind of tracker that can span terrain, undulations. But then again, the question of what does that do to the yield is a relevant point that needs to be considered in a holistic sense in the project design cycles for what it will mean for the lifetime of the asset.
Matt, we've spent a lot of this conversation talking about the practical, the physical, I guess, about software, but software is also used in financial modeling, and obviously with that there come its own issues. Could you highlight a couple of those issues in current financial modeling software?
Yeah, I mean, I think, most of the financial modeling is done within proprietary Excel models, right? So the major developers, invest a lot in sort of their proprietary look. And and I think, so I can't say necessarily there are issues with people's financial models. I would go back to the, what are the assumptions feeding into the model? And, from a strictly technical standpoint, performance is the big one. And, that's where, are we feeding the right performance assumptions into the model? Other inputs would be sort of completely different, like outlook on wholesale future energy market prices or natural gas or some others. But yeah, I mean, and I think connecting modern cloud-based design and performance tools to the financial model is really powerful. And we've got some clients that use our Plant Predict API to run 10,000 simulations a day, right? So they're iterating using big data, big computation, trying to find a way to squeeze a little bit more out of their projects, because if they're able to do financial engineering through tweaking performance, that can be a lot of value on these massive projects we see getting built.
One last question to kind of wrap up here, Aron, and if you could kind of be brief or bullet this, I appreciate that. But how can improved software solutions drive down project costs that have typically been difficult to tackle, specifically balance system or soft costs?
Sure. Yeah, I'll just echo something that Matt said earlier. Using information about the operation of your existing fleet and deriving from that knowledge what the right assumptions should be for any new project that as an asset owner or as you're looking at building as a developer, dialing in those assumptions can really solve some of those gaps that we see and drive down the balance of system cost.
Well, our thanks to the both of you, Aron Dobos from Nextracker and Matt Campbell from Terabase. It's interesting to be able to check in and get a pulse on what is an ever-changing and evolving concept.
Next, we turn our focus to learn more about equity and social justice aspects of solar.
As 2021 draws to a close, the U.S. solar industry is growing fast in size and opportunity. And while our second session will explore how to seize that opportunity, it's paramount that the industry moves forward with a focus on diversity, equity, inclusion, and justice for all workers. Joining me now is Dana Claire Redden, founder of Solar Stewards, who has spent her career working on energy equity and getting projects built in Black, Indigenous, and people of color BIPOC communities, overcoming the access and financial barriers that have held those communities back. Dana will be discussing with us today what it will take to achieve an equitable solar workforce and the benefits that come with a more diverse industry. Dana, I would love to welcome you to Roundtables 2021.
Thank you so much for having me. It's a real pleasure. So optimization, I hear that word a lot today in this amazing session with all of these leaders. And certainly the solar energy industry knows about optimization. And that's exactly what I'm here to talk about today. I'm here to talk about business. I'm here to talk about a competitive advantage for our industry. And I'm here to pull in some data to reinforce these points. And so this is nothing new to the solar energy industry. I think we've realized that we're on exponential growth trajectory, and we've got a lot of opportunities to really capitalize on. And one of those is equity, whether that be in the community as far as what sites we can develop, or our own workforce, which will need to double by the year 2035. So looking at some stats, looking at some data, we're going back to 2015 with a McKinsey & Company study called Why Diversity Matters. And then building upon that in 2017 with a McKinsey & Company study called Delivering Through Diversity. And I encourage you to look these studies up. It is found through a global study of companies that there's a 33% likelihood that if you've got a diverse team, that your company will perform above average, a 33% output there. And that is gender and ethnic diversity. So there is no mystery to the value of diverse teams. However, and unfortunately, in the solar energy industry now, we've got a very stark and troubling disproportionate engagement in our industry. So only 8% of our workforce is Black, and 16.5% is Hispanic and Latino, with even fewer numbers for Indigenous workers. And we've got a huge opportunity here as an industry to be competitive, to perform at crazy profitability levels that are really unparalleled to other industries. And so I want to make the point that, yes, it's the right thing to do, but it's also the profitable thing to do. It's also competitive advantage for your company. And certainly we're looking at this exponential growth to enable our industry to outperform.
Thank you very much, Dana. We have a couple minutes left here in your time. Would you like to take any time to highlight another organization that I know you're involved in, BOSS?
Sure. There are lots of Black-owned solar professionals and entrepreneurs in this space. And so we came together last year to create BOSS, Black Owners of Solar Services. And so we are a fledgling trade organization that has done some amazing things collectively to showcase the value of our firm. So anytime anyone says, you know, where are the diverse suppliers, we're looking for them, make sure to check out BOSS, Black Owners of Solar Services.
Yeah, thank you very much, Dana. We appreciate you taking the time to join us here today at Roundtables 2021. And we will be collaborating with Dana on some content, and especially collaborating with some of the leaders within BOSS, doing some highlights on the incredible work that they do in the coming months. So any PV Magazine readers, keep an eye out for that.
Thank you so much.
Tim, we have covered a lot of ground during our first session today. We've looked at the impacts of climate change it's having on solar, on new tools for detecting microcracks, and heard from a panel of experts on the promises and challenges of large format panels. We've also looked at some of the promising advancements in software and heard how design specs and field installation practices can have really major impacts on system performance and reliability.
That's right. Following our networking break, which is coming up next, we reconvene at 2 p.m. Eastern Time for our second session, which includes the Department of Energy's own Garrett Nielsen and a panel of sessions on how to clear obstacles to allow for a rapid ramp in solar deployment. You will not want to miss those discussions.
And we do want to take a moment to thank our partners for this year's roundtables. None of this would be possible without the support of our partners. It was great so far to welcome CEA, Longi, Arctech Solar, Endurans Solar, Nextracker, PVEL, STS, and Stobli to this first roundtable session.
Let's move to the networking break. So take some time to explore the expo area. You can find partner booths, videos, articles, and more. And you can get in touch directly with some of our event partners like STS and Endurans Solar. You can also network with other attendees one-on-one via the event app. They're 5-minute sessions, so please be patient if you're waiting to connect. Today's content doesn't just pause with the break, as PV Magazine USA's own Ryan Kennedy will be joined by Dr. John Balfour, President and Chief Technology Officer of High Performance PV, to discuss tweaking the traditional solar business model to deliver PV as energy infrastructure. Much of what they go over will be referenced in the second session. It's a topic that I've talked about with Dr. Balfour before, and it's frankly riveting, so you won't want to miss out. And also, let us know what you thought of this first roundtable session by giving us feedback in the survey popping up any moment here. You'll have the chance to win a subscription to our global magazine. Thanks for joining. For now, from David Wagman, myself, Tim Sylvia, and on behalf of our colleague Jonathan Gifford, goodbye and see you at 2 p.m.